All right, this is our lesson on area of figures. Our goal for today is I can find the area of rectangles, parallelograms, and triangles. If you want to go through the notes and see how you feel about this, you can rate yourself with a 1, 2, or 3. 1 being, oh, I don't know how to do any of this. 2 being, I remember all my formulas, but there's some problems I might not be able to do. And 3 being, yeah, I know how to do all this. All right, so this is find the area of the rectangle. So funny story, my niece, who's in 5th grade, Piper, called me last night, and she was doing problems that were asking her, the area of a rectangle is 628, and the length is 15. Find the width. And she had to do long division to find the width. So I know that we've been doing this since at the very least 5th grade, right? All right, so I asked her, how do you find the area of a rectangle? And she said length times width, and that is correct. So area is length times width. So we have the area is equal to the length and the width are 3 and 2. Multiply those two, and it's 2 centimeters times 3 centimeters. So we get area equals 3 times 2 is 6, and centimeters times centimeters is centimeters squared. That's why area has square units. All right, here it says area is measured in terms of how many 1 by 1 squares can fit inside the object. If each line below is 1 centimeter, find the area of the following figures. So if I count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 centimeters squared. Now, a faster way would have been 1, 2, 3, 4 times 1, 2, 3, 12. Okay? This one's way harder to count because there's like this piece and this piece and this piece and this piece, right? So how do we count it instead? So what you could do is you can make it into a rectangle. Okay. Count the area of the rectangle. 1, 2, 3. 1, 2, 3, 4, 5, 6. So the area of the rectangle is 18, but it's half of that, right? I need to get rid of this part. So divide it by 2, and we have 9 centimeters squared. So if you look, we have 1, 2, 3, 4, 5, 6, and then this would make 7, this would make 8, and this would make 9. But I didn't know that before I started, or did I? So area is the measure of how much space is inside a given region. We describe area in terms of the number of 1 by 1 squares which can fit within the region. In this chapter, we'll develop formulas for finding the area of each quadrilateral that we have studied. So my advice is to not try to strictly avoid memorizing the formulas, but instead to try to understand where they came from. That way we'll make it easier to understand. So for this one, we got the 12 by doing the 4 times 3. That's how we count rows and columns faster. This one, it was half of that. So I know it's just the same formula for a rectangle, but half of it for a triangle. Okay? All right, so speaking of rectangles, once again, this is the length, and this is the width, or this is the base, and this is the height. So we're going to say the formula for area of a rectangle is base times height, lowercase b times lowercase h, or length times width. I use base times height a majority of the time, but when I was talking about my niece, they don't do base times height in 5th grade. They do length and width. Okay, let's find the area of each rectangle. Make sure you have your units on it, okay? So once again, area of a rectangle, base times height. So the area is equal to, my base is 4 feet, my height is 3 feet. So the area is 12 feet squared. This rectangle right here, area equals base times height. Area equals, I need the base, I need the height. All right, so the base is this piece right here, which is the same as this, but it's not labeled, so I'll skip over it for a second. The height is perpendicular to that. So the height is 5. So I need the base, which is unknown right now. So what I'm going to do is I'm going to call it x. And remember, rectangles have right angles 4 right angles to be exact. So what we have right here is a right triangle. So what we can do is we can find x by using the Pythagorean theorem. So I'm going to say x squared plus 5 squared equals 13 squared. X squared plus 25 is equal to 169. Subtract 25 from both sides. X squared is equal to 144. Square root, we're only taking the positive answer, so I'm not going to do plus or minus, 12. So the length, or the base, is 12 centimeters. So now I can put a 12 in here. Remember, that's 12 centimeters and 5 centimeters. Area equals 12 times 50 is 60 centimeters squared. All right. All right, let's look at this in a coordinate plane also, okay? So what we're going to do is we're going to graph the following coordinates. It's telling us in the directions that these are rectangles, and then we're going to find the area. So just be careful with graphing. I have -4, 3, that's left 4, up 3. 5, 3, that's right 5, up 3. 5, -6, right 5, down 6. And -4, -6, left 4, down 6. Now I'm going to connect these 4 points to make my rectangle. Notice I have 2 vertical lines and 2 horizontal lines, so this one's super easy. I'm going to say I notice it's a rectangle. It says it in words. Area equals base times height. Area equals, I need the base and I need the height. All right, bases and heights are always perpendicular. Remember, these are square units, so we're counting how many boxes there are. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So the length here is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. So the height is also 9. So it's technically a square. So I have my base is 9, my height is 9. So my area is 9 times 9, 81. And then these aren't inches, these aren't centimeters. We don't know what they are, so we call them units. So we're going to say 81 units squared. All right, let's try another one. So we have 1, 5, 3, 2, -3, -2. And -5, +1. So if you look at this right now, since we have the ability to make straight lines, it's pretty easy to tell that this is a rectangle. But if you really wanted to make sure, you could always check out the slopes and make sure opposite slopes are the same. And then after that, that consecutive legs have opposite reciprocal slopes. So what I mean by that is that if you look at the slope of this line right here, rise over run, okay, it's up 1, 2, 3, 4, over 1, 2, 3, 4, 5, 6. 4 over 6 simplifies to 2/3. Same thing goes with this one right here. It's up 4 over 6, which simplifies to 2/3. And if you look, it's up 2 over 3. And then if you look at the slope of this line, it's down 3, right 2, which is -3 over 2. So they are opposite reciprocal slopes. Therefore, they are perpendicular. Okay, so just so we realize, we don't have to check it. It says it in words. But if we did need to prove it, we could. All right, remember, bases and heights are perpendicular. So this is my base in red, and this is my height in pink. Okay, those are my perpendicular lines. But they're not a vertical and a horizontal line. So I have to figure out that length another way. We are going to use a vertical and a horizontal line. So for this pink line, what I'm going to do, sorry, the red line, I'm going to turn it into the hypotenuse of a right triangle, because I can count vertical and horizontal distances. This is 1, 2, 3, 4. So this is 4. This is 1, 2, 3, 4, 5, 6. This is 6. So now I can use Pythagorean theorem to find the hypotenuse. So I'm going to do 4 squared plus 6 squared equals, I'm going to call it x squared. 16 plus 36 is equal to x squared. 52 is equal to x squared. Square root, don't worry about the plus or minus, and I get root 52. Now, I'm not going to round that to a decimal yet because I'm going to round my final answer if necessary. I also forgot to start by putting area equals base times height. Area equals, I need the base and I need the height. I just figured out that the base is root 52, right? That this piece right here was root 52. Now I'm going to do the same thing with the height. I'm going to treat it as a hypotenuse of a right triangle. Make this into a right triangle. Here's my right angle. This is a distance of 2. 1, 2, 3. This is a distance of 3. Pythagorean theorem, 2 squared plus 3 squared equals, I'll call that one y. I don't want to call it x also. 4 plus 9 equals y squared. 13 equals y squared, square root, and I get y is root 13. Now I can put this in my calculator. So I'm going to put it in my calculator the exact same way that it looks right now. So I'm going to do parentheses, square root of 52. If you look at my calculator, I'm still underneath the square root, so I have to toggle to the right to get out of it. Close the parentheses. So I'm typing this right here. Open a parentheses. Square root of 13. Oops. Square root of 13. Get out of the parentheses. Or sorry, get out of the square root. Close parentheses. Hit enter. And it's 26. All right, so the answer is area equals 26 units squared. Sometimes we get a decimal. This time we didn't. But let me also explain why it's a nice answer. So what you could also do to get this answer is you can multiply the numbers underneath the radicals. The radicals is just a fancy name for square roots. 52 times 13. And this is the same thing as the square root of 676. If you put square root of 676 in your calculator, you can see that that itself is 26. Okay, let's move on to our next figure. Our next figure is a triangle. So remember, we already talked about our triangle formula. It's the same formula as a rectangle, base times height, but we divided that by 2. So instead of writing divided by 2, I like to say times a half. But let's write down both in case you prefer that one. Base times height divided by 2. Or base times height times a half. Whatever you would prefer. All right, our base and our height still have to be perpendicular. So I see a horizontal piece right here. That's going to be my base. So I need a vertical piece for my height. My height is my altitude, which is not drawn in this triangle. So I'm going to drop an altitude, make a right angle to show that it's an altitude. This is my height. Always perpendicular. All right, let's find some areas of triangles. For a triangle, area equals 1/2 base times height. Area equals 1/2 times base times height. All right, so I need my base, which is 11. I need my height, which is 5. Now you might be saying, like, what? How'd you know that? I see a horizontal and a vertical line. Horizontal line, vertical line, they're perpendicular. That's your base and your height. All right, now I need to multiply these two. So I want to show you a couple ways to put this in your calculator or to do mental math. I like to multiply these two numbers first, 11 times 5, unless one of them is even, but that's 55. And then divide that by 2, take half of it. Half of 55 is 27.5. But let me show you how to type in your calculator also. So I would type, if I was typing this in my calculator, 11 times 5, enter, and then divide that by 2. 27.5. And then what was my unit? Feet. Feet squared. Next one right here, one area equals 1/2 base times height. All right, area equals 1/2. I need the base and I need the height. The base is this length right here. 6 plus 2 is 8. And the height is perpendicular to that, which it's not labeled. So what I'm going to do is I'm going to call it x. And then I'm going to find it using this right triangle, Pythagorean theorem. X squared plus 2 squared equals 7 squared. X squared plus 4 equals 49. subtract 4. X squared equals 45, and then square root to solve. Square root of 45 is a decimal answer, so I'm not going to get a decimal right away. My final answer will be a decimal, which will round to the nearest tenth. So I'm going to do 8 times the square root of 45, enter, and then divide that by 2. 26.8 centimeters squared. It doesn't say to round to the nearest tenth if necessary, but I know that's what we'll put on the test if anything. All right, let's try these next two. Graph your triangles. 5, -3. 1, 4. -4, -3. Make this into your triangle. Area equals, I'm going to do base times height divided by 2 just to show you that we can switch it up. Okay, area equals, I need my base, I need my height, and then I need to divide that answer by 2. All right, bases and heights are perpendicular, and I see a horizontal line, so that makes me happy. That's going to be my base. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. All right, now I'm going to drop my altitude. So I'm going to go from my vertex, which is opposite of that base, right? Drop it until it hits this side perpendicularly, and then count how long that is. And I want a vertical line, remember. 1, 2, 3, 4, 5, 6, 7. So base 9, height 7. So in my calculator, 9 times 7, enter, 63. Divided by 2, 31.5. So area equals 31.5 units squared. All right, here's the next one. -6, 1, 0, 1, 4, 5. All right, so area equals 1/2 base times height. Area equals 1/2 times base times height. So my base is 1, 2, 3, 4, 5, 6. And my height is 1, 2, 3, 4. Remember, I need to come from my vertex, which is opposite of that, and drop it to the base. This altitude is outside, so it's 4. I counted from here because I just looked how tall from the bottom to the top of the triangle is. So the base is 6, and the height is 4. Area equals 12 units squared.